Welcome to section 3.2. Let's begin by discussing the difference between independent and dependent events. For two events to be independent, one event cannot affect the probability of the second event occurring. For two events to be dependent, the outcome of one event affects the probability of the occurrence for the second event. Let's give an example of two events that are independent. For two events to be independent, as we stated above, one event in no way can affect the probability of the second event from occurring. Let's take tossing a coin and rolling a die. Let's assume that the die has 6 sides. We'll say what's the probability of tossing the coin and having it land on heads, and rolling the die and having it land on a 5. Well, rolling a die and having it land on a 5 is 1 out of 6. If I toss a coin first, that's 1 out of 2 for it to land on heads. Still, the probability remained 1 out of 6, showing that they are independent events. Let's talk about a deck of cards. What is the probability that I select a king from a deck of cards, return it to the deck of cards, and then select a queen from the same deck of cards? Well, the probability of withdrawing the king, of course, is 4 out of 52. When I place the king back into the deck of cards, the probability of withdrawing the queen is 4 out of 52. That 4 out of 52 on the queen was the same whether or not I removed the king and placed it back into the deck. Two events that are dependent. Well, we're going to return to that deck of cards again. This time we're going to say we're going to remove a king from a deck of cards and see what the probability is for withdrawing a queen on the second card. Well, normally the probability of withdrawing a queen would be 4 out of 52. If I withdraw a king from that deck of cards, do not replace it, and then withdraw a queen, the queen's probability would be 4 out of 51, showing that it was affected by the fact the king was not returned. What does the notation P parenthesis B/A mean? Well, what that means is the probability of event B occurring given that event A has occurred. Let's talk about true and false. If two events are independent, then the probability of A given B is equal to the probability of B. Now, if the events were independent, then the probability of A occurring given that B has occurred would be equal to the probability of A. This is suggesting that the probability of A would be equal to the probability of B, and as you know, that's not a true statement. The next set of problems we're going to move on to has to do with very careful reading. We're given a table below, which is right here. We're going to answer these questions. Find the probability that a randomly selected student is male, given that the student is a nursing major. Once I recognize my given, that's always going to be my denominator. So in this case, my denominator is referring to the fact that the student is a nursing major. If I look at the nursing majors, there are 819 nursing majors. So 819 would be my denominator. I'm going to put 819 here on my denominator. I'm going to take a look now to go back to see what my numerator would be. Find the probability that a randomly selected student is male. Well, of my male students, I have male students that are both nursing majors and non-nursing majors. But I want to know the male students that are nursing majors, so I'm going to put that 94 over top of my 819. Let's move on to part B. Find the probability that a randomly selected student is a nursing major, given that the student is male. This time I'm given the fact that the student is male. This is going to change things around a little bit, because if the student is male, I'm going to have a different result in this case. So, the student is male. The total number of males that I'm looking at in a case like this so of course there's 1,198 males. Of the 1,198 males, 94 of those males are nursing majors. So that's going to be 94 over 1198. Let's take a look at the next set of problems, which are for problem number 8. The table below shows the results of a survey in which 142 male and 145 female workers ages 25 to 64 were asked for at least 1 month's income set aside for emergencies. Find the probability that a randomly selected worker has 1 month's income or more set aside Find the probability that a randomly selected worker has 1 month's income or more set aside for emergencies, given that the worker is female. Because the worker is female, I have a total of 145 females. Now I want to see if they have 1 month's income or more set aside. Well, of the females, how many of them have more than 1 month set aside? So I have 83 and 62 being listed here. I want to see what this is referring to, though. Find the probability that a randomly selected worker has 1 month's income or more set aside. Well, 1 month's income or more is the second line, which would be 62 out of 145. Let's read the second one. Find the probability that a randomly selected worker is female, given that the worker has less than 1 month's income set aside for emergencies. All right, well, let's take a look at less than 1 month's income set aside for emergencies. Well, less than 1 month's salary put aside for emergency is 149 people. So we'll do 149 as our denominator. Now we're going to read that again. Find the probability that a randomly selected worker is female. So I have to see which ones of those are females. So of the 149, 83 are female. So 83 females of the 149 people total that we're looking at in that set.